going to be doing by hand. So here goes. For the years of 1983 to 1990, the number of mountain bike owners, M, in millions, in the U.S. can be approximated by the model where M equals 0.337 t squared minus 2.265 t plus 3.962. Over the interval 3 is less than or equal to t, which is less than or equal to 10, where t represents 1983. Okay, so what that means is t, bad start so far, huh? So t equals 0 at 1983. Okay, so that means 1984, we would have a t value of 1. And in 1985, we would have a t value of 2, and so on and so forth. Now, when we're talking about over the interval 3 is less than or equal to t, which is less than or equal to 10, a t value of 3 actually represents 1986, which would mean a t value of 10 would represent 1993. So just to give you a little perspective as far as what we're looking at here. So looking at A, it says, in which year did 2.5 million people own mountain bikes? Okay, so when we're talking about millions of people, as far as bike owners, we're referring to M in our equation. So we've got an M value here of 2.5, which means we're trying to find T. All right, so let's go ahead and do that. So I'm going to plug in, I'm just going to scroll down a little bit here. So I'm going to plug in 2.5 for M. Okay, bear with my writing here. And I'm just going to fill in the rest of this here with our equation that was given to us. Oops. Okay, so now that that's all plugged in, I'm going to bring this 2.5 over to the other side so that I can get the left side all zeroed out. I will try to get rid of the sound effect that the stylus makes when I write. Bear with me. All right, so we've got this lovely quadratic here that, I don't know about you, but it does not look like fun to factor. So instead of factoring, I'm going to plug these guys into the quadratic formula. Now, 0.337 is our A, negative 2.265 is our B, and 1.462 is our C. So let's go ahead and plug those in. So in the quadratic formula, I'm going to put t equals instead of x equals, since we are representing t as our independent variable. Our negative b, so I'm going to go ahead and just write a positive 2.265 here, plus or minus the square root of b squared. So I'm actually going to do some calculations ahead of time just for the sake of space here on my board. So b squared, I'm going to round a little here. I'm going to take it out to about 5 decimal places because that should still give me a pretty accurate answer. So I'm going to say b squared is going to be 5.13023. I'm also going to do minus 4 times a times c. And again, I'm going to go out to about 5 decimal places here just because I know these numbers are going to go on and on and on. So I'm going to say 1.97078. And all divided by 2a, which is 0.674. Okay, so continuing to simplify here. And again, taking this out to about 5 decimal places here so that I get an accurate final answer, but it's not going to be exact, which is okay because these numbers are kind of funky. Okay. All right, so now I'm going to go to my calculator again, and I'm going to type in 2.265 plus the square root of 3.15945 divided by 0.674, And then I'm going to do the same thing, but I'm going to subtract them. And we should come up with two different t values. So the first t value ends up being, and again, rounding here, about 5.99775. And the second t value is about 0.7233. I'll just throw another number in there. Okay. All right. So looking at our t values, both of them are positive, which is great. However, only one of them falls within our domain, and that is 5.99775. This guy does not fall in the domain. So we are going to formally reject this t value. And we're going to take a look at the 5.99775. Now the question asks, in which year did 2.5 million people own mountain bikes? Well, technically 5.9975 falls within the 5th year, so 5 years after 1983. Now it's obviously with the 9975, we're talking about towards the tail end of that 5th year. So if we're talking 5 years after 1983, that's 1988. So in which year? We're going to say in the year 1988. Now we know this is very, very close to 1989, but when it asks, kind of exactly, obviously our numbers aren't perfect here, but when it asks for exactly in which year, technically it's in the year 1988. It's just very late in that year when we reach this 2.5 million bike owners. Okay? All right, so now looking at part B. In what year was the number of mountain bike owners at a minimum? All right, so we know anytime we talk about minimum and maximum, we're talking about the vertex. Now, specifically here, it says in what year. Now, in what year represents the x value, or for us is the t, the x value of the vertex. Now, we know how to find just the x value of the vertex. Remember, the x value of the vertex is the same as the axis of symmetry. So I'm going to use, instead of x equals, I'm going to say t, just for the sake of our problem. T equals negative b over 2a. Okay, so I'm going to plug into that formula. Negative our b value, which is negative 2.265, divided by 2a. Okay, and simplifying that, I get approximately, and again I'm rounding here, 3.36053, and this is to give me an idea of in what year. Okay, so in what year? It looks like we're in the 3rd year, and if we're talking about a t value of 3 or 3 years after 1983, we're talking about the year 1986. So that's what year we have a minimum value. Okay, so hopefully that wasn't too painful. I promise the next couple of numbers are going to be much nicer. So let's go ahead and take a look at number 2. The value of Sophia's stock portfolio is given by the function v of x equals 50 plus 73x minus 3x squared, where v is the value of the portfolio in hundreds of dollars and x is the time in months. Okay, don't be nervous with the function. We all know that it's not in standard form, but we can still work with it. How much money did Sophia start with? Okay, so how much money? So we're looking for a value here. We're looking for v. Now, when it's asking how much she started with, we're looking at a time of 0. So 0 months have passed. So our x value here, which represents time in months, is going to be 0. And we are going to solve for v. So let's go ahead and do that. So v of 0, just plugging into our function, is 50 plus 73 times 0 minus 3 times 0 squared. So everywhere there was an x, I put a 0. All right, so simplifying all of this, v of 0 equals 50 plus 0 minus 0. Okay, easy enough. So v of 0 equals 50. Now remember, This value is in hundreds of dollars. So if that's the case, 50 times 100 is going to give us $5,000. And that is how much Sophia starts with. All right, so let's keep going. When will the value of Sophia's portfolio be at a maximum? Okay, max and min mean vertex. Now in this case, it's saying when will the value be at a maximum? Okay, so if we're talking about when, we're talking about time. And in this case, again, we're talking about the x value of the vertex because our x represents time. Okay, so to find the x value of the vertex, let's go ahead and use that axis of symmetry formula again. Okay, so plugging in x equals negative b. Now be careful here. So working backwards, the negative 3x squared, that's our a value. Our a value is always attached to x squared. Our b value is always attached to x. And our constant is always our c value. So when I say negative b, I'm saying negative 73 divided by 2 times negative 3. Okay. So I'm going to move this up here for a sec and actually do my dividing. And I end up with, again, I'm just going to round because really I'm looking for this more to help me with my answer. It's not going to be perfect, but it's going to give me a good idea. So x equals 12.1667. So when will the value of Sophia's portfolio be at a maximum? Well, x representing time in months, it looks like sometime during the 12th month is really when she's going to reach that maximum value. So our final answer is going to be during the 12th month. And it looks like it's going to be towards the beginning of that 12th month. Okay, hopefully we're doing okay so far. Let's try one more question. All right. A foul ball leaves the end of a baseball bat and travels according to the formula h of t equals 64t minus 16t squared, where h is the height of the ball in feet and t is the time in seconds. How long will it take for the ball to reach a height of 64 feet in the air? Okay, so how long refers to time, and in this case, time is represented by t. Will it take for the ball to reach a height of 64 feet in the air? Okay, so I'm giving you an h value here of 64. All right, so I have an h. I don't know t. That's what I'm looking for. So let's go ahead and plug in the 64 for h, and let's solve for t. All right, so here's our equation again. Okay, where it says h of t, I'm going to plug in 64 because that's the height I'm looking to reach. And I'm trying to figure out how long it takes the foul ball to get there. Okay, all right, so noticing I only have one t squared value here, it's obvious that in order for me to solve for t, I'm going to have to solve a quadratic. So we know that we can factor and use the quadratic formula and complete the square. In this case, I'm going to probably try factoring first. Now, in order to do that, I'm going to bring this negative 16t squared and positive 64t over to the left side. And the reason for that is I don't really feel like factoring with a negative t squared, so let's make it positive. All right, so I'm going to do two things at once here. I'm going to add 16t squared and subtract 64t. Add 16t squared, subtract 64t. So let's just do two things at once. Okay, so my left side, writing this in standard form, 16t squared minus 64t plus 64 gives me 0. Alrighty, I see a GCF right away. Now you can either divide every single term by 16 and make it go away entirely. What I'm going to do is I'm just going to factor it out on the left side, so it'll still be present. It's not going to make too big of a difference or too big of an impact on my final answer, though. It's just kind of hanging out for the remainder of the problem. Alrighty, so looking inside my parentheses, I know I can factor this using AM. Factors, or I should say multiples, or factors that multiply to 4 that add up to negative 4 are negative 2 and negative 2. Okay, so applying the zero product property, again, 16 equals 0, that really does nothing for me. But this t minus 2 and the other t minus 2, those make an impact. So noticing I get the same t value, great, we'll take it. That makes life easy on us. We don't have to reject anything. It looks like when t is 2, so which means after 2 seconds in the air, the foul ball is going to reach a height of 64 feet. Okay, so how long will it take for the ball to reach a height of 64 feet? 2 seconds.
All right, guys, number 4. By the way, that was Mrs. Waters working through numbers 1 through 3. If you couldn't tell, that wasn't my voice. So I'm just going to finish up with number 4. DJ hits a golf ball off the tee. The height of the ball is given by the equation y equals negative 16x squared plus 4013x plus 3250, where y is the height in yards above the ground. That should say x. Let me go back. Oop, nope, we're going to leave that y. Sorry. This should say x. And x is the horizontal distance from the tee in yards. Sorry about that, guys. Okay, how far does DJ hit the ball? So if you think about what this parabola would look like, I'm just going to do a quick sketch here. We know the parabola is going to open downward because the leading coefficient is negative. So if I just make a really rough sketch of maybe what this would look like, probably something like this. So I'm going to write up here, we know this is the height of the ball, and this is the distance. Okay, so if we're looking for how far he hits the ball, we're looking for this point right here, because that is where the ball is going to hit the ground and at what distance it's going to hit the ground. So really what we're looking for is the x-coordinate of that point. So in order to figure that out, we are going to have to find what one of those x-intercepts are. And to do that, we have a couple of options. We can solve this using quadratic formula, completing the square, factoring. Because of the types of numbers we have, I'm probably going to go with quadratic formula. Okay, so at that point, we know the y-coordinate is 0 because the ball has hit the ground, so it has 0 height. So I'm going to put 0 in for y, and x is what I'm trying to find. My equation looks like that. Okay, so if I'm going to do quadratic formula, let me list over here my a, b, and c. So a is negative 16, b is 4013, and c is 3250. Okay, so remember your quadratic formula is negative b, in this case negative 4013, plus or minus square root of b squared minus 4ac all over 2 times a. Okay, so let's do some simplifying. Negative 4013 plus or minus. That squared is 16104,169. And if I multiply negative 4 times negative 16 times positive 3,250, I get positive 208,000. And then all over negative 32. Okay, I'm going to show one more line of work here. I'm going to add what's inside my square root to get 163,12169 divided by negative 32. Oops. And so what I'm going to do at this point is type this in my calculator. So remember, when you do that, the whole top of your fraction should be put in parentheses if you're not going to use the fraction key on your graphing calculator. And you can't put plus minus. So the first time you type it in, you're going to put plus, get your answer. Then remember, we can copy and paste it and change that plus to a minus. So if you type it in correctly, the two answers you should get are negative 0.81 and positive 251.62. Okay, so if you think about this number that you got being the distance that this ball went, we're going to reject the negative. It doesn't make sense that we would have a negative distance. So the one that we want to use is the 251 yards. So how far did he hit the ball? 251.62